Okay, today you're going to be writing equations of parallel and perpendicular lines. If you recall, you did do this last year. The core concept with parallel lines and slopes, two lines in the same plane that never intersect are parallel. Two distinct non-vertical lines are parallel if and only if they have the same slope. So parallel lines have the same slope. And note all vertical lines are parallel. In example 1, line A passes through -5, 3 and -6, -1. Line B passes through 3, -2 and 2, -7. Are the lines parallel? Well, you'll have to do a few calculations. One, you'll have to calculate the slope of both lines. So for line A, the slope equals, remember, the change in y over the change in x. So we'll have -1 minus 3 over -6 minus the -5, which is -4 over -1, which is equal to 4. For line B, remember, slope, change in y over change in x. We have -7 minus the -2 and 2 minus 3, -5 over -1, which is 5. So the answer is no. And the reason, because it does say to explain, they do not have the same slope. So if the answer would have been yes, if the two numbers, if the slope calculation had been the same, your explanation could be that they do have the same slope. In example 2, we want to write an equation of a line that passes through -4, 2 and is parallel to the line y is equal to 1/4 of x plus 1. So since we want the line to be parallel, we know that it's going to have the same slope, so I'm going to start by recording that the slope will be positive 1/4. I'm going to use the point slope formula. If you recall from yesterday's lesson, y minus y1 is equal to m times the quantity x minus x1. And the subscript y1 and x1 are going to come from the point that they provided. So y minus 2 is equal to our parallel slope, x minus the -4. And I'll notice my mistakes as I go, so sorry about that. I'm going to do some simplification here. I'll distribute, and then I'll solve for y. So y will be equal to 1/4 of x plus 3. In perpendicular lines, the two lines in the same plane that intersect to form right angles are perpendicular. Non-vertical lines are perpendicular if and only if their slopes are negative reciprocals. So this is kind of important. Perpendicular slopes are negative reciprocals. Vertical lines are perpendicular to horizontal lines. So kind of look at the slope right here, this -2x. The negative reciprocal of that would be a positive 1/2. So determine which of the lines, if any, are parallel or perpendicular and explain. So the first step you're going to want to do is make sure they're all in slope-intercept form. I see that line B is already in the right form, so I'm going to change line A and line C into slope-intercept form. Making sure to put the slope term right next to the equal sign. Solve for y. We already said that line B was okay, so let's go ahead and change line C. Okay, now the first thing I want to do is compare the slopes. In line A, I have a negative 1/3 of x, line B, a positive 3x, and line C, a positive 3x. Remember, lines with the same slope are parallel, so lines B and C are parallel because they have the same slope. And then I look at the difference between line A and B and C, since they're the same, and I notice that line A is the negative reciprocal of the other two. So line A is perpendicular to both lines B and C because the slope is the negative reciprocal. And remember to pause the video if you need more time to copy things down. Write an equation of the line that passes through negative 3, 5 and is perpendicular to y is equal to negative 3x minus 1. So the first thing I want to do is write the negative reciprocal of this negative 3x, which would be a positive 1/3. I'm going to be using the point slope form, and this will be x1, y1. So I'll substitute in those values, and I'll substitute in my new slope. I'll simplify. I'll distribute. And then I'll solve for y. And I'll get y is equal to 1/3 of x plus 6. Okay, our final example is going to come from the tutorial on big ideas.
A helicopter is at 8:5. The shortest flight path to the shoreline is one that is perpendicular to the shoreline. Write an equation that represents this path. Begin by finding the slope of the line that represents the shoreline. The line passes through the points 1, 3, and 4, 1. So the slope is m equals the quantity 1 minus 3 divided by the quantity 4 minus 1, which simplifies to negative 2 divided by 3, or negative 2/3. Because the shoreline and the shortest flight path are perpendicular, the slopes of their respective graphs are negative reciprocals. Negative 2/3 times 3/2 is negative 1, so negative 2/3 and 3/2 are negative reciprocals. So the slope of the graph of the shortest flight path is 3/2. Use the slope m equals 3/2 in the point slope form to write an equation of the shortest flight path that passes through 8:5. Substituting 3/2 for m, 8 for x1, and 5 for y1, you get y minus 5 equals 3/2 times the quantity x minus 8. Distributing the 3/2 through the quantity x minus 8, you get y minus 5 equals 3/2 x minus 12. Now solve for y by adding 5 to each side, giving you y equals 3/2 x minus 7. So an equation that represents the shortest flight path is y equals 3/2 x minus 7.